Okay, finally we've created a recommender model here in Azure that includes both the user item rating triple on this donors choose data, and then we've got user features, but just one, whether or not a donor is a teacher, and that improved things ever so slightly. But now we're going to take a much larger jump here, and we're going to include all of the rest of the data that we have in this data set, which includes information about projects, information about resources, schools, and teachers. So this is all the other data that came with this donors choose data set. And all of this I'm characterizing it as information about the items, about the project we want to donate to, which that makes sense for this table right here, this data set. And as you take a look at it, you can see lots of good information here about the project. A bunch of foreign keys there tying it to those other tables. Teacher project posted sequence. I forget, I'm not sure what that means. Project type. So there's some categorization there. Project title, essay, short description. I'm not going to go through and do natural language processing on this because I have that in another example in the book. I want to keep this one a little bit simpler. But we do have these other interesting things here like product category subject, grade level, resource category cost, the year, month, and weekday it was posted, current project status, and then a bunch of others here. It looks like it pulled in a bunch of empty columns. We can just ignore those. So that's good info, but then we also have info about the resources being requested. So I've got a project ID that could be listed multiple times. So for example, this one right here, with many different resources requested, a quantity for each, a cost for each, suggested vendor. So this is more good information here, but I can see that there's a one-to-many relationship with project, and that could be problematic because each project ID can only be listed once in the item features table. So we're going to have to do some sort of aggregation on this table where we combine all the records for this project into one with some meaningful value. Well, we could add up resource unit price, but there's already a project cost listed in the cost table, so that might not help much. We could, though, get the max price and the min price and see if projects that have only really expensive or at least some inexpensive resources requested, maybe they get more funding. Also, we could add up the quantity, total number of resources requested or something like that. So we'll do another SQL aggregation to combine all these records into a single one. Next, we've got schools and teachers. These have a one-to-one relationship with projects, so they're pretty easy to tie in. Information about the school. So if I'm donating to a project, it's for a particular school, and maybe there's details of that school that are relevant that'll explain why I am willing to donate there, like school metro type, school free lunch percentage. I think we'll leave this location stuff out of it for now, just to keep this example a bit more simple. Then finally, teachers. Let's see what we have in here. Is there anything useful? Teacher ID, teacher first project posted date. We could do a current date minus this to see how long the teacher's been posting projects. Maybe they get better over time, and that would explain why somebody would want to donate to a particular project. We've got features or a teacher prefix, so we can see if there's like a gender effect of some type. Let's keep it simple, and we'll just use this one, and I won't worry about feature engineering a number of days that this teacher's been posting projects. So first thing we'll have to do now is to merge all of these together. Let me resize this with hitting the 0 key. So to do that, let's grab the join data pill. And join data, think of it as just a simple primary key, foreign key, inner join feature for data that already exists, rather than doing it in SQL, pulling it from a SQL database. So for example, projects to resources, there's a project ID here and a project ID there. In a one-to-many relationship, we take the primary key out of the one side and put it in the many side. So that means I can come here and say, grab project ID, check, tie it to project ID in the resource table, check. All right, now let's include schools next, and to do that we'll grab another join data right here. Alright, I'm going to be a little OCD and try and keep this aligned. Alright, pull that over there, pull that over there. How are these ones going to join? Well, you might remember from the project table we had a school ID in there as well as a teacher ID. So that's how we're going to tie that one together. This join data is going to have everything above it, including school ID from the projects table. Check. And then this side will have school ID. And then one more join data. Bring together teacher ID from here and teacher ID from there. Teacher ID matches up with teacher ID. Okay, it's going to automatically bring in all the other features from all 4 data sets and bring them through here. So we're going to want to, actually let's get to that point first so you can see, and then let's pull on a select columns to pick only a few of the features out, a sampling from each table, just so that we can use it in the example, but keep it not too complicated. We're already getting pretty deep here. Alright, that's complete. Let's take a look at what we have. Okay, all columns from all 4 tables are now included here, including those blanks or empties. Sorry that I have those in there. I didn't realize that have been added. And notice, see this teacher ID too? It's because we have teacher ID from 2 different tables and it's labeling each of them. So what we need next is a select columns pill, and we're going to grab only what we want. So let's pull that in. And actually, you know what, before I do that, I can accomplish sort of the same thing with an apply SQL transformation. We're going to have to run that aggregation that we did over here when we had multiple donations from a person for a project. So we'll hold on to this select columns for just a minute, and for now let's come here and write this up. So I want a few tables. I'm going to copy this in since I already have it in another place, and you can copy it if you'd like. Okay, so here's what I have. I've got select, let me bring these over, project ID, and now I'm going to need that, and that has to be the first thing selected so that this table can be matched up with project ID from the user item rating triple table. And pull that over. Oops. I'm going to pull group by over. Try to keep things nicely aligned here. Oops. Alright, so I want all of these columns. Let me stretch this over here. Project ID, teacher posted, project posted sequence, project type, project cost, year, month, weekday, project current status, days to funded, days live, school percentage free lunch, teacher prefix, and then I've got 4 aggregated columns. So I'm going to sum resource quantity so I can get the total number of items requested. And this is going to be, I didn't use a keyword as, but it gets the idea, as sum resource quantity. So I'm going to give that a new name. I'm going to get the max of resource quantity so I can know what's the, are they asking for a whole lot of one particular type? Does that make people feel like there's a huge need and they want to donate more? Min resource unit price, so are there very inexpensive things being requested? Maybe people will like that. Or max unit resource unit price, maybe some people are looking to donate a lot more. So when I run my group by, I include everything in my select except for my aggregated selections. So I just copied that and pasted it right down here. Okay. Now that I've got this SQL, let's run to this point. Oh, and select is going to get mad at me unless I put something in there. What can I put in there? Project ID for now. I'm just trying to get rid of that red exclamation point that was right there, or else this wouldn't have run. So let me just run this apply SQL transformation. Okay, let's take a look. So what this does for me, besides generating some new aggregated features, it re-normalizes the table so that each project ID is only listed once. And then I have these aggregated columns for all of the entries for each project. And it also allowed me in my select statement to only pick out the other columns that I wanted to test out and try. So I got rid of all those project IDs, school IDs, resource IDs, teacher IDs, and all that. So what I want to do for now, we're going to use this more later, but for now I want to bring through everything. So project ID does need to be first. I'm just going to grab all these, bring them over, check. And then let's plug this in where item features go in both train recommender and score. And then let's see what we get. All right, let's see what we have here. Evaluate recommender. We're looking at I think the item recommendation, if I remember right. Yep, NDCG score. So before we were up to a 0.9408 or something like that, and now we're down a little bit. Well, does that mean that all of our item features are bad and they're hurting our model? Well, at least some are. Well, how do I know which ones? I don't have that ability here in Azure ML Studio. So what can I do to find out which of these features I've created or selected here I should actually include in my model? Well, there's a few things you can do. And the best one may be to simply build a regression model off of this data and then examine the feature importance to see which features are having the biggest effect. So to do that, I need to predict something relevant that explains why people would want to donate to a project. Well, that's just the donation amount over here. So what I'm going to do is add another join data pill to tie together this data right here. And I think what I'll do is go from apply SQL transformation on this side, since the select columns is currently including everything. But I'm going to use it to reduce what we take down in here into our recommender model in a bit. But I'm going to join this data to the data over here, and I think what I want to do is let's join after we've completed all of our math operations right here. Okay, so let's select the primary key for both, project ID and project ID. Inner join like before. Actually, I'm going to change my mind and bring it back up here again, I guess. All right. After that, we are going to need, I guess I'm going to need one more select columns because I want to get rid of the project ID columns. So let me run that one. And while it's running, oh yeah, refreshed on me. I guess I can just copy paste this one once this is done running. Okay, copy paste. Let's eliminate project ID now. Okay, but I want donation amount in there so that now I can use that as my label. So now we're just going to do a basic split train score evaluate for a regression model. Split, let's do, we'll leave it as 50-50 because we have a ton of data. 1, 2, 3, 4, 5. Here's our score, grab the train. Actually, you know, we really don't even need to score it or evaluate it. We're really just interested in permutation feature importance. This is what's going to tell us which features matter the most. So let's connect our split data down here. Oh, we will need an algorithm though. Train model goes here, other side of split data there. train model, tell it we want to predict donation amount. Which algorithm should we use? Well, you could make a case for a couple of them. This recommender uses a naive Bayes based algorithm. So why don't we start with that one? But really we're going to try a few, and what I want to do is try a few algorithms and see which features tend to always be towards the top of permutation feature importance. Now, before I do this, one thing to keep in mind is let's take a look at the format that the data is currently in after we've joined it here. Okay, we have each donor ID and project ID listed once. However, that's not the format we're looking for. We are looking to have each project ID alone listed once. We don't want to have project ID repeated for every person who donated to it. That's going to violate some of the assumptions of our models and repeat a whole lot of the data. So what we want to do is add one more apply SQL transformation pill, and this time we're going to use it to aggregate all of the donations together for particular projects. So I'm going to move this down about right there. Bring in this pill, connect, whoops, connect. All right, and in my apply SQL transformation, I'm going to select, let me grab everything once again. Let's see here, I might have a quicker way of doing that. Well, I guess I can grab it from this one. So I'm going to get all of these. I know it's kind of a pain here. This is how it works. Alright, select all of that from T1. However, we renamed these to max resource quantity and max resource unit price. And I don't need to rename these now. I guess I could have just kept the ones there on the right. Then we got a couple more here. See, these have already been previously aggregated, and so I don't need to re-aggregate them here. Okay, perfect. Alright, let me stretch this out just to remind you what we're looking for here. Alright, so we're going to select these same, oh, I missed a few though. You know what, I think I must not have copied this first line right there. Copy. There we go. Let's just stretch it out, make sure I didn't miss anything. Right there. Alright. No, I still missed. But you know, we don't need project ID anyway. We wanted to get rid of that. So technically that's what we were using this search columns for. So I apologize, but I'm going to take that right back out and just connect this SQL transformation right down there. So let me check one more time. Project ID, then teacher project ID or teacher project posted sequence. So this is actually supposed to say teacher project posted sequence. There we go. Project type, cost, everything else from T1. We still need to group by this same list up here. I'm doing things a little bit out of order. That's okay. Group by all of those. But we'd add one more aggregated field up here. So let's do a sum of donation amount. So this will become our label right here, and we'll call this sum donation amount as donation amount. Okay, this will become our label. The rest of these are our features. Let's minimize this now. in our train model, okay, we still have donation amount. Now each project should only be listed once in our data set. So with a total sum of donations. So let's give this a moment. All right, now my permutation feature importance is taking a bit of time here. As you can see, I'm up to 4 minutes, and I don't think I want to wait. Let me just show you a couple things. First, now that we've aggregated, notice that we're down to 10,000 rows instead of 40,000 something rows. But rather than wait for this to finish, I just want to show you the results of several different runs. So here's that Bayesian model predicting the sum of donation amount. Our top feature was project cost. And then I changed out the naive Bayes and used a boosted decision tree model. Still project cost is the top feature. Decision forest model, still the top one, but notice the second one changes there. And then I changed that apply SQL transformation to, rather than use the sum of donation amount, the count of donation, meaning how many total people donated. And in here, the R squared was a lot smaller for this model, so I'm not sure if I trust it quite as much, but regardless, project cost was always still in the first one or two. So it looks to me that it's clear that project cost is going to be a useful feature. Days to funded shows up as the number 1 or number 2 3 times. Project current status shows up number 2 days to funded. So here's what I want to do. Let's go back in here into select columns, and let's check or make sure that we include only those top two, project cost and days to funded, that were most consistently towards the top. You can experiment with a bunch more of these if you want to, but I'm going to just start with these two to keep this example short. Click OK, and then run your experiment and check and see our metric. We got 0.94034134. How does that compare to what we got before with the kitchen sink model where we just threw everything in? All right, before we had 939, so we're a little bit higher now, not a ton higher, but enough that we've been able to make a slight improvement. In general, in this data set, the user and item features didn't happen to add a lot. Other times, it'll add a ton. So it just depends on the data. But hopefully the point is made. This is how we include item features and an example of how we can get a little bit of help determining which features are most useful to put into the model. And you can do the same thing, of course, with user features as well. So let's stop this video right here, and we'll proceed with one last one to give an example of how to deploy a model like this.